I want to provide some homework help for you on page 371. This is part 2 of section 7.2. We're dealing with division of radicals in this part of the section 7.2. So let's just take a look at a few of your homework problems. Number 26, we said today that we have a principle regarding division of radicals that says two separate radicals being divided could be thought of as a single radical of a fraction. So I'm not hurting anything in this problem if I rewrite what's given as the blue radical. And the reason why I'm doing that is because I want to emphasize something that will make simplifying this a lot easier. Notice that this fraction can be reduced or simplified because 250 divided by 2 is 125. And we can reduce or simplify these x's that are being divided because x to the 7th divided by x squared is x to the 5th. And similarly, we can do the y's. Y cubed divided by y is y squared. So what we thought was simplifying the cube root of a fraction, really, when it comes down to it, it can be simplified into non-fraction form, which is a lot easier to deal with. So just like we looked at yesterday, I would like for you to break this up into radical factors. Two cube radicals that are being multiplied together. This left radical will represent only perfect cube root numbers or variables, and the right radical will represent the non-perfect cubes. So I noticed the number 125, and hopefully we're getting used to the perfect cube numbers. 125 does have a perfect square, a cube root. So I'm going to put it on the left side, which represents all the perfect cube numbers or variables. X to the 5th doesn't have a perfect cube root, but I can break it up into x to the 3rd, which is a perfect cube, times x squared. Okay, those two multiplied together would equal x to the 5th. Now y squared, nothing I can do to simplify that. 3 does not divide into 2 evenly. So I'm going to have to put all of y squared in my right group, which is all of the terms, numbers, variables that cannot be simplified with a cube root. All right, so let's simplify this left radical. The cube root of 125 is 5. The cube root of x cubed is x. And then that's going to be multiplied by this other radical, the cube root of x squared, y squared. So that is your answer for number 26 on your homework. All right, let's take a look at number 31. Now, when we're rationalizing, and your instructions here say to rationalize the denominator, and we looked at that in class today, we need to come up with a way using multiplication to remove the radical expression from the denominator. And for roots that are not square roots, and for example cube roots and fourth roots like we have in this problem, what we're trying to do is multiply by a radical, a fourth root expression that would produce a perfect fourth root number in this case. Okay, so it might be helpful just to make a perfect fourth list, and you might want your calculator for this one. We can start with 2 to the 4th, which is 16. And then we would think of 3 to the 4th, which is 81. Okay, well, so far I'm looking and I'm trying to figure out some number that I could multiply by 5 that would give me a number from my list. And so far, there is no way to multiply a number times 5 to get 16. There is no number to multiply by 5 to get 81. So I'm going to have to keep looking. So my next 4 to the 4th, 4 to the 4th is 256, or in other words, the 4th root of 256 is 4. Still not able to multiply by a number to equal 256. So I'll give you a little, these are the roots. 4th root of 16, 4th root of 81, 4th root of 256, in parentheses. So let's try 5, okay? So in your calculator, if you want to do 5 to the 4th, that's 625, okay? So I noticed that obviously it should be possible to multiply 5 times a number to equal 625. Okay, they both end in 5. 5 is a factor of 625, and that would be 125. Okay, so what we've done here is we found the radical that would multiply by 5 that would produce a perfect 4th root radical. Okay, and since we're going to have to multiply the bottom by the 4th root of 125, then we're also going to multiply the top by the 4th root of 125. Okay, so the numerator is going to be the 4th root of 250. And the denominator it's the 4th root of 625, which we've already discovered is just 5. So we can erase that radical and put 5. Okay, and as it turns out, as you can tell, none of our perfect 4th root numbers divide evenly into 250. We can't do any canceling, so this ends up being our final answer for number 31. I just wanted you to see how we have to find that number, that radical that would multiply by the given radical to, in this case, produce a perfect 4th root radical expression. Okay, so hopefully that helps. So let's try number 32. Usually people end up doing a lot more work on number 32 than is necessary. Let's see if we can reduce this by using our principles of two radicals being divided. Can be thought of as one single radical of a fraction. Well, first of all, what is 15 divided by 3? Well, that's pretty easy. That's just 5. And if we did think of this as just one radical of a fraction, we're going to have the radical 60 divided by 12, which is 5, and x to the 5th divided by x, which is x to the 4th. So a lot of people jump in and they start multiplying by the square root of 12x on the top and bottom, and they get a very big number that they end up having to simplify. And if you do it right, eventually you'll end up with the right answer, but it's so much easier when you can cancel like this to take care of the canceling first. Then you can pretty easily simplify this radical. And again, using radical factors, I would say the square root of x to the 4th, which is perfect, times the square root of 5. So my final answer looked like it was going to be a lot of work, but as it turns out, it's not too bad at all if you know how to approach the problem. So your answer for 32 should be 5x squared times the square root of 5. All right, I think I got one more for you. And once again, you could cancel here as well if you like. You could, in other words, make this become the square root of 5x squared. Notice how you could do x to the 4 minus 2 power, okay, over the square root of 2y squared. Okay, you see how we did, we canceled. Basically, you can think of dividing both of these by y, or you could use your rule of exponents. 1 minus 3 is negative 2, which puts it as positive 2 in the denominator. I'm not saying you have to do this. You could have just jumped right in and multiplied top and bottom by the square root of 2x squared y cubed, and then you would just have more reducing to do at the end. I'll leave that up to you. It really doesn't matter. But I just went ahead and did some reducing at the beginning. And now I'm going to multiply top and bottom by this bottom radical. Since it's a square root, I'm going to multiply top and bottom by the square root of 2y squared. Okay. So the top product would be the square root of 10 x squared y squared. And the denominator is just going to be 2y squared. And a radical times itself is just what we call the radicand. All right, so let's simplify this numerator. And hopefully, without writing two separate radical factors, hopefully you can see that that's just going to be x, y. These are both perfect square variables. Square root of x squared is x, square root of y squared is y. And the square root of 10 cannot be simplified over 2y squared. Okay, and now we see an opportunity to cancel. All right, and the canceling is going to occur with these y variables. So you can think of it again as dividing y into both. Y divided into y is 1, and y divided into y squared is y to the first. So bottom line answer is going to be x times the square root of 10 over 2y. Okay, and that should be your answer for number 34. All right, so I hope those 4 problems helped you. That's a pretty good sampling of your overall homework assignment. So if you still have questions, please come see me during academic support. And we'll check these out tomorrow.